In order to simplify this, let's rewrite this. Remember that every radical can be separated. For example, if I have radical 25, this is the same as saying radical 5 times radical 5. Or if I have radical 64, this is the same as saying radical 4 times radical 16. So if we separated this, it could be radical 4 or square root of 4 times radical x to the fifth. So we can evaluate square root of 4. That's going to be 2. So the other thing to remember is that when we have a radical expression, such as we have here, the number here is called the index, and here we have the power. Whenever we have an index, it's always going to represent a fraction of power. So what we're doing here, as an example, is x to the a raised to the 1 over b. Basically, what we would end up with is x to the a over b. So another way of thinking about this is that the index is going to be the denominator, and the power on our radicand is going to end up being the numerator for our new power. So if we were to continue, so again, we know that we had square root of 4 times x to the square root of x to the fifth. Square root of 4 again was 2. And for the x to the fifth, whenever they don't write an index, we know that the index is 2. So square root is something that has an index of 2. So that means that if we were to rewrite what we have here, it's the same as saying x to the 5 over 2, which is the index. So this is our answer. We can again separate these. So this would be the cube root of 27 times the cube root of y squared. The cube root of 27 is 3 because 3 times 3 times 3 is 27. And for the other portion of what we have, we know that we're going to have y. We know that the index is 3, and our power on the radicand was 2. So it's going to be 3 times y to the 2/3. Feel free to pause the video and try this yourself just to see if you have a good grasp of what's going on. Okay, so this is the answer. So now if we separate it, it would be the cube root of 125 times the cube root of a to the negative second times the cube root of b. The cube root of 125 is 5 because 5 times 5 times 5 is 125. For the second portion, for our second factor here, we know that the base is a, the index is 3, so we're going to have a denominator of 3. The power on the inside is negative 2, and so negative 2/3 would be the power of what we had there. For our third factor, we know that we have a base of b, we have an index of 3, and we have, when the power is not written, it's actually 1. So we have 1/3 for our power. Let's rearrange this so that we only have positive exponents. So that b to the negative 1, because of our reciprocal rule, is going to end up in the denominator. So this whole thing is a to the third times b to the 1, or just b. So now let's rewrite this so we don't have any radicals. One thing to note is that, again, we're dealing with an index of 2. So we could, if we wanted to, express it this way. 2 over a to the third, b to the 1, all of that is being raised to the 1/2 power, because that's what the square root is. So our rule says that we're going to apply this 1/2 to every single part of what we have. So this is going to mean that we're going to end up with 2 to the 1/2 over a to the 3/2 and b to the 1/2, because we're multiplying the powers. If we were to rewrite this one, what I notice first of all is that 16 is the same as 2 to the 4th power, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So what we have here is basically 2 to the 4th power, which is then raised to the negative 3/5 power, which is then raised to the 5/4 power. And whenever we raise a power to a power, we have to multiply it. So we're really multiplying three numbers here. So let's see what that would look like. So if we did 4 times negative 3/5 times 5/4, that should be our new power. Of course, we can make this 4 over 1 if we wanted to. Some of this is going to simplify out. So this 4 is going to simplify with this 4, just like how this 5 is going to simplify with this 5. So all we have left now is negative 3 over 1, which is just negative 3. That means that our answer is going to still have the base of 2, but our power, because we're raising a power to a power and multiplying, our new power is going to be negative 3. So try this problem, see what you come up with, and let's compare. So you can pause it at this point and try to see if you come up with the same answer. So you were likely tempted to do the following. So you probably did power to a power, so you multiplied that 2 in the 1/2, and you multiplied the 2 in the 5/2, and you said 2 times 1/2 is going to be 1, so it'll be x to the 1, and then 2 times 5/2 is 5, so it'll be x to the 5, and we're done. Or you might have just said x plus x to the 5th. So this is wrong. Please, please do not do this in calculus. This is completely wrong. So we can't do that because of the fact that we're adding here. So we have to have either multiplication or division in order to do what we just did. So addition or subtraction, this is not going to work. So what we have to do instead is to think about, well, what do they have in common? So it looks like they have x to the 1/2 in common. So I could possibly factor out an x to the 1/2. So x to the 1/2 times 1 will give us this x to the 1/2 right here. The x to the 1/2, let's see, x to the 1/2 times x to the 4/2, we add the powers, gives us x to the 5/2. So if I'm going to factor out an x to the 1/2 out of this term, then I'm going to be left with x to the 4/2. Multiply it back and see for yourself that we'd end up with exactly the same thing. So all of what we have here can be written as this factor. But remember that everything was being raised to the second power. So we're going to raise this to the second power. So notice that now we're actually multiplying. So we can use the power to a power rule or the expanded power rule. So what we're going to say is that this 2 is going to be applied to each factor. It's going to be applied to the x to the 1/2, and it's also going to be applied to this quantity here. So if we do x to the 1/2 raised to the second power, then we multiply power by power, and it's just going to be x to the 1, or just x. If we have x to the 4/2, well, that's easy. That's just going to be x squared. So we should be able to rewrite everything the following way. This is equal to just x times 1 plus x squared raised to the second power. Or if you prefer, x times x squared plus 1 raised to the second power. If we multiplied everything out, we would end up with x times x to the fourth plus 2x squared plus 1, and then we multiply by x again, it gives us x to the fifth plus 2x cubed plus x. So this is our final answer. In order for us to work this out, the first thing that we probably notice, or again, pause this if you want to try it yourself. But the first thing that we notice is that everything here is either multiplication or division until we get to inside here. So if we're dealing with just everything on the outside, there is a factor that should cancel out. So this 2 and this 2 is going to divide out, which means that we should be able to rewrite everything as x to the 1/3 times 3x to the 1/3 minus 4x to the 1/3 all over x to the negative 1/3. Notice that what we have inside the parentheses, that these are like terms, so we should be able to combine them. So when we combine everything, it's going to look the following way. It'll be x to the 1/3 times, so 3 minus 4 is negative 1, so it'll be times negative x to the 1/3. And this is being divided by x to the negative 1/3. We want to remember that negative powers create reciprocals. So if we dealt with what's in the denominator here, then it's going to come up into the numerator. So it's going to end up being x to the 1/3 times this is going to be x to the 1/3 positive times negative x to the 1/3. So some people get a little nervous seeing this negative here, but we can just factor the negative 1 out and make it x to the 1/3 times x to the 1/3 times x to the 1/3. When the bases are the same, we add the powers. So what do you get from 1/3 plus 1/3 plus 1/3? So that's going to be 3/3 or 1. So this is going to end up being negative 1 times x to the 1. In other words, it's just negative x. Pause this and try this yourself first and see if you come up with the same answer that I do. So because of power to a power, this 5 is going to be multiplied by this entire power of 2n minus 1. And also, because we're multiplying in the denominator where the bases are the same, we're going to have to add the powers. So when we do both of those things, this is what we're going to end up with. In the numerator, we'll end up with x to the 10n minus 5. In the denominator, we're going to end up with x to the n plus 3. And now, because we're dividing, we have to, and the bases are the same, we have to subtract the powers. So if we have 10n minus 5 and we subtract n plus 3, then basically what we have is 10n minus 5 minus n minus 3. So these two combine to be 9n, and these two combine to be minus 8. So all of this is going to end up being x to the 9n minus 8. Some of us might try the easy way out on this particular problem, but this addition is going to get in the way. So what we could do is we could just rewrite this and think about what it actually means. So what we have is 2 to the negative 1. So because it's a reciprocal, I'm just going to write 1/2. In the denominator, I have 2 to the negative 2. Again, because it's a reciprocal, I'm just going to write 1/2 to the positive second power. And then the last part would be 1 over 2 to the third, again, because it's a positive power. So how do I get rid of these fractions? I could multiply by the largest denominator, which is 2 to the third. So I'm going to multiply this fraction by 2 to the third over 2 to the third and see what happens. So in the numerator, it would end up being 2 to the third over 2. In the denominator, remember we're multiplying this 2 to the third times the entire denominator. So it would end up being 2 to the third over 2 squared plus 2 to the third over 2 to the third. So our numerator, so 2 to the third divided by 2 is just going to end up being 2. 2 to the third divided by 2 squared is going to be 2 to the 1. And 2 to the third divided by 2 to the third is just going to end up being 1. So when we simplify everything, this just ends up being 2/3. So for what we have here, we can rewrite everything to have a base of 3. Because notice that 27 is related to 3, just like how 1/3 is related to 3. So 1/3 is really 3 to the negative 1. "27 is 3 to the third power. So what we're dealing with is the square root of 3 to the third power being raised to the 8th power. This, of course, is the same as the square root of 3 to the 24, because when you raise a power to a power, you multiply the powers. So on the left-hand side, when we raise a power to a power, we multiply them. So negative 1 times x minus 1 is going to give us a negative x plus 1. So what we have on the left side is basically negative x plus 1. So on the right side, notice that we have an index of 2. So we can rewrite this as 3 to the 24 over 2. And on the left, we have 3 to the negative x plus 1. 24 divided by 2 is 12. So if we rewrote everything, what we would have is 3 to the negative x plus 1 equals 3 to the 12th power. So because the bases are the same, that means the powers have to be equal. So in other words, negative x plus 1 is equal to 12. If we subtracted 1 from both sides, we end up with negative x equals 11. And if we divide both sides by negative 1, then that means that x is equal to negative 11. On this particular problem, it would be useful to remember a bit of number sense or algebra. That if we multiply, for example, 3/2 times its reciprocal, which is 2/3, that we end up with 1. So we're going to apply that. So let's say that we took this whole left side and applied a power of 2/3. And we did the same thing on the other side. We applied a power of 2/3. So on the left side, we would have 2 to the 2/3 times 1 minus 4x. And that this would equal basically 16 to the 2/3. We could divide both sides by 2 to the 2/3, and we end up with 1 minus 4x is equal to 16 to the 2/3 over 2 to the 2/3. So on the right hand side, we can make that a little bit easier because 16 is 2 to the 4th power. So we have 2 to the 4th power raised to the 2/3 power over 2 raised to the 2/3 power. So if we use the quotient rule, we're basically saying that we started out with 2 to the 4th divided by 2, and all of that was raised to the 2/3 power. 2 to the 4th divided by 2 to the 2nd is 2 to the 3rd. So we have 2 to the 3rd being raised to the 2/3 power. So power to a power means that we multiply them. So if we do 3 times 2/3, what would that be? Well, we could put the 3 over 1, multiply everything out, and we would end up with 2 over 1, which is just 2. So in other words, this is equal to 2. So we have 1 minus 4x equals 2. We can use basic algebra, subtract 1 from both sides. So we have negative 4x is equal to negative 3, is equal to 1. And then we divide both sides by negative 4. And so x is equal to negative 1/4. One strategy that we could try here is a U-substitution. So we could say, suppose that u equals x to the 1/3. And if we squared both sides, then we're saying that u squared is the same as x to the 1/3 raised to the 2nd power. Power to a power means that we multiply them. And remember that 2 times 1/3 is 2/3. So in other words, this is going to end up being x to the 2/3. So if I see x to the 2/3, I should be able to replace it with u squared. And if I have x to the 1/3, I should be able to replace it with u. So this is how we can rewrite the problem if we know that. So x to the 2/3, we said we're replacing that with u squared. And that's going to be minus 7 times u plus 12. So we can factor this. This is going to factor as u minus 4 and minus 3. So if we solve for either side by setting it, either factor by setting it equal to 0 using the zero product property, that means that u can either be 3 or u can be 4. So in other words, either x to the 1/3 is 4 or x to the 1/3 is 3. So if we raise both sides to a power of 3, in other words, we do a power to a power, on the left side, 3 times 1/3 is 1, so we would just have x to the 1. 4 to the 3rd power is 4 times 4 times 4, which is 64. So one possible value of x is 64. We could do the same thing on the other part of what we have. If we raise that to the 3rd power and raise the other side to the 3rd power, then we would end up with x is equal to 3 times 3 times 3, or 27. So these are our possible answers. On this problem, feel free to pause it, see if you can come up with an answer. There are multiple strategies that we could use, but a few things that we want to remember. If we notice that we're adding 1 here, that means that basically what we did was 3 to the 1 times 3 to the 2x to get 3 to the 2x plus 1. So we can rewrite this as 3 times 3 to the 2x minus 10 times 3 to the x plus 3 equals 0. We could use another U substitution here. Let's say that we let U equals 3 to the x. So U squared means 3 to the x raised to the second power. Power to a power means that we multiply that, so that's going to be 3 to the 2x. So now U squared is the same as 3 to the 2x. And then U is the same as 3 to the x. So if we substitute everything, then this would mean that we would have 3u squared minus 10u plus 3 equals 0. Let's see if we can factor this. So 3 times 3 is 9. And here we have negative 10. So two numbers that multiply to be 9 but add to be 10, I would say 1 and 9. And since the product has to be positive, they both have to be negative or positive. And since the sum has to be negative, then if they're both negative, then that works out fine. So this would look like 3u squared minus 1u minus 9u plus 3. So factor by grouping, we can take out just a u out of the first part, so it'll be u times 3u minus 1. And out of the second part, we should be able to factor out a negative 3. So it'll be negative 3 times 3u minus 1. So our factors would have to be u minus 3 and 3u minus 1. So in other words, our factorization on the left here would be u minus 3 and 3u minus 1. If we solved each one by setting them equal to 0, then we would end up with u equals 3 on the left and u equals 1/3 on the right. So in other words, 3 to the x is either equal to 3 or 3 to the x is equal to 1/3. Keep in mind that 1/3 is the same as 3 to the negative 1. And that 3 is the same as 3 to the 1. So what we have is either that x is equal to 1 or x is equal to negative 1. And those are our answers.